Two objects are connected by a light string that passes over a frictionless pulley, as in figure 5.26. Draw free body diagrams of both objects. If the incline is frictionless, and if m1 equals 2 kilograms, m2 equals 6 kilograms, and theta equals 55 degrees, find A, the accelerations of the objects, B, the tension in the string, and C, the speed of each object 2 seconds after being released from rest. In this problem, you are given that m1 equals 2 kilograms, m2 equals 6 kilograms, theta equals 55 degrees, and t equals 2 seconds. First, before you do anything else, you need to draw a free body diagram for both objects. The circular object, m1, has gravity acting on it downward, denoted as m1g, and tension acting on it upwards, denoted as t. Its acceleration due to the pulley is upward. The rectangular object, m2, has tension acting on it to the left. Gravity, denoted as m2g, acts downward on it. Because we are looking for the force of gravity with respect to the incline the object is on, we have m2g sine theta acting in the opposite direction of tension. Its acceleration is in the same direction as the force. Part A asks for the acceleration. To do this, first we must find the sum of the horizontal forces for the second object and vertical forces for the first object. Since F equals m times A, the second object's sum of horizontal forces is m2g sine theta minus t equals m2a. The first object's acceleration is downward, so we must find the sum of vertical forces, which is t minus m1g equals m1a. Now add these two equations together. The tensions will cancel, leaving you with m2g sine theta minus m1g equals m1a plus m2a. Now you need to get a alone. You can factor it out of the right side of the equation to get m2g sine theta minus m1g equals a times m1 plus m2. Then dividing both sides by m1 plus m2 gives you a equals m2g sine theta minus m1g over m1 plus m2. Now plug in all the numbers, and A comes out to be 3.57 meters per second squared. Part B asks for you to find the tension in the string. To find the tension, take the equation t minus m1g equals m1a and solve for t. Adding m1g to both sides gives you t equals m1a plus m1g. Factoring out the m1 gives you t equals m1 times a plus g. Now plug in the numbers, and t comes out to be 26.7 newtons. Part C asks for us to find the velocity 2 seconds after the objects are released. Since v initial equals 0, we can use the kinematics equation v equals a times t to solve for v. Now plug in the numbers for a that we found in part 1, 3.57 meters per second squared, and the time given to us in the problem, t equals 2 seconds, to get v equals 7.14 meters per second.